Emily, this is Mrs. McCreary. Since you were having questions and couldn't really pinpoint it, I was just going to work through some of the problems that you were being asked to do from pure mathematics. So just kind of bear with me because I'm going to try and do this as quickly yet thoroughly as possible. Okay, so here I'm going to make this a little bit bigger for you. Oops. Hopefully the issue isn't just seeing the problems. If it is, there's all your numbers. Okay, so it says reduce the following to improper fractions. I'm going to go ahead and use 35 and 12/17. Okay, there we go. So we have 35 and 12/17. So since we want it in improper fractions, we want to get rid of this mixed number and turn the whole thing into a fraction. We want to get rid of that integer. So what we're going to do is we're going to break this integer up into parts and then add it into our fraction. The way we're going to break our integer up into parts is to multiply it by that denominator because we want all 35 of these units to each have 17 pieces. 4, 0. Sorry. Okay, so we found out that 35 times 17 is 595. So when we break those 35 units into 17 pieces, we get 595 over 17. Now we already started with 12/17, so we need to add that in. So that is going to give us 607, I think. Let me double check that. Yeah, whatever. Yep. 607 over 17. So we have, let me go down here, our integer, our numerator, our denominator. We're going to take our integer times our denominator, and that is going to give us, I'm just going to say value, whatever, W, okay, just because I needed it to be something else, okay? So then we're going to take W, add that to our numerator. W plus our numerator is going to give us value Z, and then we have Z over our denominator. So in this scenario, let me change colors so we can see things a little bit better. My blue? Yes, okay. So 35 was our integer, 12 was our numerator, 17 was our denominator, 595 was our value W, 607 was our value Z, and then we ended up with Z over denominator here. Okay, so hopefully that helps a little bit more. Let's look at the next one. Reduce the integer 19 to sixths, tenths, 13ths, 18ths, 19ths, and 20ths. So we're going to take the integer 19 and make it tenths. Okay, so we have an integer, and again, we want it to be tenths. All right, so we're just going to multiply it by our denominator as if we had okay, so 19, sorry, going back, thinking about this a little bit more. 19 is the same as 19 over 1. Any integer can be turned into a fraction. You just put it over 1. And we want to change this to a 10. Now we can't just multiply the denominator because that changes the value, so we need to multiply the numerator too, so we get 190 over 10. So if you were working with any other denominator, when you wanted like 20ths, let's say, 19 over 1, we want to multiply that by 20 over 20, and that'll give you your 20ths on the bottom, and then 19 times 20 will give you your numerator. So again, any fraction can, or any integer, I'm sorry, any integer, because this started as just 19, can be written as a fraction. All right, let's see what the next problem is. Ooh, that's not what I wanted to do. Let's make it big again. Okay, bring the following fractions to integers and reduce them respectively to fourths, sixths, eighths, tenths, twelfths, and 14ths. That's unnecessarily complicated, but oh well. Okay, so we'll do eighths, and we'll do, how about 27 thirds? Okay, so to make, we've got our numerator, our denominator, and in this case we want to end up with our denominator being eighths. So we had 27 thirds. Now, to find out how many, to change that into a mixed number, to change an improper fraction into a mixed number, we're going to divide the numerator by the denominator, exactly what it looks like. So 27, 3, that is going to give us 9. Okay, so now we have 9. So 9, I think we said we were going to go with eighths. So 9 is equal to 9 over 1. We're going to multiply that by 8 over 8 to get that eighths on the denominator, and that's going to give us, what, 72 eighths? Okay, so numerator divided by denominator, and that hopefully will give you all whole numbers, and then you are going to multiply it by an equivalent to 1, so 8 over 8, 6 over 6, 11 over 11, whatever you need to do to get the appropriate denominator. Okay, multiply the following fractions each by 10, 11, 12. Okay, let's do 9 twelfths by 11. Why not? Okay, so we have 9 twelfths times 11. Now, here we want to multiply it by the value of 11, so we need to change 11 from integer form to fraction form, so we're going to put it over 1. All right, and now, I haven't quite gotten to this, but that's okay. 9 times 11 is 99. 12 times 1 is 12. So just whatever you're multiplying it by, make that your numerator. 1 is your denominator because you have 11 whole units, right, for the integer of 11, and then just multiply it by your fraction. Next one. How much does 8 times the fraction 29 fourths exceed the quotient of 666 37ths by 3? That's a fun question. Okay, so let's start with 8 times the fraction 29 fourths. Same as what we had before, 29 fourths times, multiplying it by an integer, we want that integer to now be a fraction, so 8 over 1 equals, I think I'm just going to go ahead and set this up and I'll let you do the computation. So that'd be 29 times 8 over 4. And I'm just going to continue to write it like that. Sorry. Okay, 666 37ths by 3, the quotient of 663 37ths by 3. So we're dividing 666 37ths by 3. 666 37ths divided by 3. So now we're going to go ahead and use that table from section 55. We want to divide. That is our goal. So we can either divide the numerator or multiply the denominator. I'm going to go ahead and divide the numerator, which is going to give me 222nd over 37. All right, and now how much does 8 times exceed the quotient? Okay, so now you're going to need to get these two fractions to have common denominators, and then you'll compare the numerators and see how much bigger this one is. So here you need the LCM, convert them to that common denominator, and then once you get that common denominator, it'll be just the subtraction of the 222 from that one. Divide the following fractions each by 6, 7, or 18, and 18, I'm sorry. Let's go ahead and do 103 and 1/7 divided by 7. 103 and 1/7 divided by 7. Okay. I'm sorry, I would like this to be a little thicker. Medium. Okay. Medium. Go away. Yes? Okay. So now in order to start working with this, we need to have it in improper fraction form, because this doesn't really help us much. Okay, so we're going to do our integer times decimal plus numerator. All of that over our decimal. Okay, so 103 times 7, 2127, plus 1 is going to give us 721 over 7. We want to divide this by 7. So again, I'm just going to call it table 55 because it's in section 55. Okay, so table 55, we're dividing, so we can either divide our numerator or multiply our denominator. I don't want to divide because I'm being lazy, so that is going to be 722 over 49. Let's see, are we done with that? Divide the following fractions. Yes. Okay, next one. Diminish the following ratios respectively 6, 7, 8-fold. That is the exact same question as number 6. It's just using ratio terminology. Okay, so let's go ahead and talk about this one right here. Okay. Probably going to have to look back at that too. Okay, so it was what, 3 and 3 something. Come on, you can do it. 3 and 3/13. That's a lot of 3's to 4. Okay, so again, we want, I didn't pick what we were doing, did I? Let's go, we did 7 before, let's go with 8. So we're going to divide that by 8. Okay, so first we want this to be a mixed number. Okay, so 3 times 13 is what, 69, I believe? Huh, 39, I was way off. Plus 3 is going to give us 42 over 13 over 4 divided by 8. Again, we can either divide the numerator or multiply the denominator. So I'm going to leave this as 42 over 13 over 32. And for the sake of right now, I don't know where they're going with this, but this is, for me, an appropriate answer. That's totally fine. Okay, simplify the expression. Wow, compound. Those are fun. Okay, we've got like 3 ofs here. Got it. How many problems do we have? Hence rule, reduce a factor. Okay, so we just have to get to number 12. All right, that's fine. Just a few more. Okay, I'm just going to go ahead and do the first one because it's right there. So it's, I believe, 1/2 of 3/7 of 5/8. 1/2 of 3/7 of 5/8 of, I don't know, 1 5/9. There we go. That's not it. Okay. So we're going to be looking at these independently. I'm going to group them off. Okay, so we have 2 sections to work with. All right, so now as we remember, or you might remember, you might not, your book tells you that when you're working with compound fractions, you're just going to multiply your numerators, multiply your denominators. Okay, so 1 times 3 is 3, 2 times 7 is 14 of 5 times, this needs to be converted first, so that's going to be 9 plus 5 is 14/9. So 5 times 14, 70, yeah, 70 is 70 seconds, and now we're just going to multiply again, so that is going to be 210. Yeah, I can't do this one in my head. 72, 14, 8. Oops, need to scooch it up. 28,027 plus 8. And okay. Whoop. Okay, now did it want it in? That's not the right one. Simplified. Well, that is certainly simplified. It's not the simplest form, but it is simplified. Okay, reduce to simple fractions. We'll go ahead and do this one. 2 1/4. Yes, so our answer before was here. 2 1/4 over 7 and, I don't know, 7 1/9 of 3 5/16, I think is what that says. 15/16, right? So, if you ever, like here, if you decided it was 1/8 or something, and you did the problem as though it was 1/8, I would not count off for that. Because, yeah, these numbers are difficult to read. Okay, so we want to deal with this denominator first. So the first thing to do is to get these into improper fractions. I guess we could put the top into improper fractions also. That's not a big deal. Anyway, so 7 times 9 is 63. So then we'd have 64 over 9 of 3 times 16. 3 times 15 is 45. So that'd be 48. 48 plus 15. 63 over 16. And they just like their big numbers. Anyway, okay, so 64 times 63, 12, 19, 6 is 24, 36, 8. Okay, that's a very large number. Wow. Okay. We'll go back and get the rest of it in just a second. It's so much smaller. Okay, so our denominator is then Oh, let's just go ahead and do our numerator too, because that's going to be a lot easier. That's going to be just 9/4. So we've got 9/4 over 4,032 144ths. 4,000? Yeah. Okay, and so now we're going to use our complex fractions of multiplying the extremes and multiplying the median, or the means, I'm sorry, and then the extremes will give you your numerator, and this will be then your denominator, I believe. Okay, so next one. Okay. What is the difference between 2 3/7 of 3 1/9 of 2 13/34 and 9 6/7 over 1 1/2? So since there's only one problem, I'm not going to do it for you, but I will tell you what to do. All of these you need to start by turning them into improper fractions, and then just go ahead and multiply your numerators and multiply your denominators. Again, here we are turning into improper fractions, multiplying our extremes, multiplying our means. And then you're going to have to make sure you have a common denominator so that then you can go and subtract. Okay, and 11, find the integral value of all of this. Okay, so we are going to again convert everything into improper fractions, multiplying numerators and denominators, multiplying numerators and denominators, get a common, least common multiple so you can subtract. Improper fraction, multiply numerators and denominators, least common multiple so you can add. And then you would divide the numerator by the denominator, so numerator inside, denominator outside. Hopefully that will give you an integer, a whole number. Okay, so add the sum of the fractions of those two fractions. Let's see if I can, no, can't erase that. Let's see, can I? There we go. Okay, you can see that a little bit better. So again, mix numbers to integers, means, extremes, common denominators, add them together, add the sum of the fractions to their difference. So you're going to add these two fractions together after you get them into simple fraction form, where again, make sure everything is in an improper fraction, and then on each of these you'll multiply the means, multiply the extremes, improper fractions, multiply the extremes, multiply the means. The extreme is the numerator, the mean is the denominator. Make sure you have a common denominator. Then you will add them, subtract them, take the sum from adding, the difference from subtracting, take those two values, and add them again, because reasons. So hopefully that explains a bit more of what you're supposed to do and how to do it. These books are asking an awful lot of you guys, and so far, Emily, you're doing a great job, so just go ahead and keep it up. Please let me know if you have any other questions.